Right. So where were we last time? Okay. In previous lecture, we have talked about boiling point. Okay, how to describe boiling point, and then we have also discussed about the difference in boiling point uh, for different substances, like what we have in the graph here. Okay, like what we have in the graph here. So we have the ether, ethanol, and water. Okay, so at 760 torr, which is equal to 1 atm, uh, when we compare the boiling point for each one of them, we can see that they have different boiling point at 1 atm. Okay, so the ether has the lowest boiling point, and then if we hit further, if we extend further, we could find the boiling point of the ethanol, okay, which is 78.5, and then we heat further, okay, the water will boils. Okay, so the normal boiling point for water is 100 degrees Celsius. So different substances, of course, may have different boiling point. Okay, so what are the factors that contribute to the different in boiling point? So one of it would be the intermolecular forces. Okay, all right. So by right, the stronger the molecular forces between the particles, okay, these forces will help the molecule strongly, and this will interfere in terms of the vaporization of the particle to the upper phase. Okay, because they are held with strong forces dekat situ. So in order for in order for the particle to vaporize, it need to overcome the forces dekat situ. Okay, so the surface will be vaporized faster. So dekat situ kalau dia punya attraction is stronger, then by right it will be harder lah to vaporize. So like water kan, water, the intermolecular forces present is hydrogen bonding, which is the strongest. So in order to vaporize, in order for the particle to vaporize to the upper phase, it need to overcome the hydrogen bonding. Okay. All right. So that is that. Next. Okay. Boiling point elevation. So kenaikan takat didih, okay, or we can represent it as delta TB, especially when the non-volatile solute is added. Okay, so what happens is that the vapor pressure of the solvent will be altered. In this case, it will be lowered. Okay, dia akan merendahkan the vapor pressure. So this, of course, okay, cause the solution to be heated to a higher temperature than the boiling point of the pure solvent in order to reach the external vapor pressure of 1 atm in order for boiling to occur. Okay, because non-volatile solute will not vaporize. Instead, they occupy the space of the solvent, okay, initially. So dekat situ it won't vaporize. So the amount of particle that going to the upper phase is now decreasing. So kalau decrease, that means we have to heat the solution further. Okay, we have to heat the solution further because bila bila number of particle vaporize decrease, so by right the vapor pressure pun also decrease. Okay, bila vapor pressure decrease, that means it will not be the internal and the external are not the same. Okay, in order to reach the boiling point, the internal and the external should have the same pressure. So how can we increase the internal pressure? Okay, so one of the way is to heat further the solution. When we heat further the solution, more more particles can be vaporized, okay, and thus produce more vapor pressure ataupun higher vapor pressure, and eventually the internal pressure or the pressure of the solution will be the same as the external pressure. Okay. So this means that the presence of non-volatile solute elevates the boiling point of the solution. Okay, all right. So this is the formula that we use to calculate the boiling point elevation. Elevation means kenaikan takat didih. Kenaikan means dia ada sebelum dan selepas. Okay, so how do you explain the kenaikan? Dia mesti ada initial temperature. Sebelum dia macam ni, when when the solute is added, they become this temperature. So it is actually the difference in temperature. Okay, that's why we represent it using delta ataupun segitiga ni, which explain the difference between the two temperature. Okay, right. So this is the formula. So delta TB depends on the concentration of the solute given by the expression. So concentration in this case is described in terms of molality instead of molarity. Okay, so we are going to be using the molality of solute. So delta TB is equal to KB. KB in this case is the molar. The constant, the boiling point elevation constant of the solvent. So this is the constant lah. So it should be given in the question unless you are asked to find the constant. Okay, all right. Then delta TB can also be determined simply by minus the the temperature of the solution, the boiling point of the solution, okay, minus with the boiling point of the pure solvent. Take for example, we have a solution air garam lah, okay, salt solution, aqueous solution. So the temperature may be 103. So this is after apa nama tu, water, okay, and with added solute. Okay, and then we know that water, the temperature is the boiling point of water. This is the boiling point of solution just now. So the boiling point of water is 100 degrees Celsius. This is only water. Okay, so to find out the difference between these two, so the boiling point of the solution minus the boiling point of the pure solvent, which is equal to 3 degrees Celsius. Okay, all right. So that is why the boiling point of the solution, the temperature, the boiling point of the solution should be higher than the boiling point of the pure solvent. Okay, so that's why nama dia boiling point elevation, kenaikan boiling point. So initially it is lower. So once the solute has been added, it become higher. Okay, alright. So the delta TB, the value should be more than 0. Kalau you dapat negative value, that means you salah kira. Okay, so it should be more than 0 sebab dia kena yang besar tolak yang kecil. Okay, alright. So this is the phase diagram. The phase diagram. The y-axis is pressure and the x-axis is temperature. Okay, so in this phase diagram, we could see this is phase diagram for water. Okay, this is the phase diagram for water. As you can see, we have ice, which is in solid state. Okay, and this is supposed to be liquid lah, sebenarnya dia ada reason kenapa dia tulis ni aqueous solution, tapi sebenarnya awal-awal in comparison, okay, should be solid and then liquid and then this is gas. Water vapor is in gas state. Okay, alright, so liquid. So for the liquid and solid and also the liquid and gas dekat sini, nampak tak dia ada line macam Y ni dekat sini. Okay, so the green one actually represent the pure solvent. Okay, alright. So maksudnya kalau pure solvent, dia punya boundaries je, solid to liquid is this one. Ni boundaries je. Maksudnya kalau dia pure, this is also considered as solid. Di dalam keadaan solid. Okay, same goes to this one. This area should be in gas phase. This is the area of the gas yang ni. Termasuk this one. Okay, because liquid is only within this green line sahaja. Alright, so this is for pure water. Alright, when we add solute into the water, what happen is that apa yang berlaku adalah dia jadi solution, right? So it become aqueous solution. So dia akan jadi extended sikit, nampak tak? The boundaries is no longer the green line, so dia akan jadi yang merah ini. So nampak tak colour hijau dia tu dia dah apa nama tu, dah melebihi lah garisan hijau tu. Okay, so dia extended further tau, So the pink line tu represent the solution. Okay, the pink line to represent the solution. That's why sebenarnya dia tulis aqueous solution ni is actually the region is already extended dekat situ. Okay, it's already extended. So menunjukkan apa? Apa yang nak tunjukkan dekat sini? Okay, alright. So bila this is, okay, label dulu. This is for the solution. Okay, this is solution also. The pink line represent the solution. The green line represent the pure solvent without the solute. Okay, alright. So we mentioned about the boiling point elevation and freezing point depression kan. Cuba tengok. Bila apa nama tu, boiling point means water will be transformed into gas. Okay, water will be transformed into vapor, which is the liquid here will be transformed into yang pink ni dalam bentuk gas. Right? So kalau dia dah jadi solution, tengok the difference between the green dengan pink tu tadi. Okay, at this pressure is also equal to 1 atm because this is in kilopascal. Okay, if we convert into atm, it is supposed to be 1 atm. So kita buat dashes ni kan. Kita pergi kat boiling point dulu Boiling point meaning that the liquid will transform into gas. Okay, liquid will transform into gas. Okay, kita jumpa garis hijau ni dulu, betul tak? Garis hijau ni sebenarnya represent the boiling point. Okay, the boiling point daripada liquid nak jadi gas. Kalau terbalik dia pergi ke sini, maksudnya it is condensation point. Dia daripada gas nak jadi liquid. Okay, since we are talking about boiling point, so kita nak pergi ke daripada liquid kepada gas. Daripada hijau kepada pink. Okay, so this is the boiling point of the pure liquid, water, pure liquid. Okay, alright, so as you can see, we got 100. Okay, at 1 atm ataupun at this 101.3 kilopascal, the pure water punya boiling point is 100 degrees Celsius. Okay, if dia jadi solution, that means the solute is added into the solution. Nampak tak? So maksudnya dia dah jadi kat colour pink ni. So kita kena extend further. Kena pergi lebih ke kanan. We have to move to the right until we came across the pink dot kat sini. Maksudnya which is here lah at 1 atm. Okay, we are talking about 1 atm. So kita go down. This is the boiling point, okay? These two is the boiling point, but the boiling point of the solution. This one is the boiling point of the pure solvent. Pink one represent the boiling point of the solution. Okay, bila kita turun, nampak tak? So the temperature now has increased. So maybe this is around 105 degrees Celsius. Contoh. Okay, so as you can see, it is increased. So the boiling point is said to be elevated, menaik. Okay, what good thing about this phase diagram adalah we'll be able to see it clearly in terms of the boiling point elevation and freezing point depression at once. Kita boleh nampak dia. Okay, alright. So this is boiling point elevation. How about freezing point depression? Okay, freezing point depression maksudnya from liquid to form ice. Okay, so maksudnya dia daripada liquid, which is this one yang colour hijau ni liquid nak jadi ice. So maksudnya dia pergi ke kanan lah. Okay, melting on the other hand dia terbalik, the opposite. Daripada solid becoming liquid. Okay, alright. So, okay, like I said, yang green tu is for the pure, right? Okay, so dekat 1 atm. Okay, because that is the normal pressure. So here would be kita nak going to the left, right? So this one will represent the freezing point of the pure water, which we know that it is equal to 0. Okay, all right. So this is for the pure. Okay, how about the solution? When the solute is added into the solution, dia akan move to the left. Dia move to the left ni. Baru jumpa yang color pink ni. The pink one represent the solution. Okay, all right. So we move to the left, and then we finally came across the pink dot. I mean pink line ni dekat sini. Okay, at the same pressure. Kita check on the freezing point is no longer 0. Okay, it is depressed. Okay, dia lowered ataupun decrease to lower than 0. Okay, right. So we could say that when solute is added into the solution, the boiling point will be elevated and also the freezing point will be depressed. Nampak tak? Kita boleh nampak benda tu serentak dalam this phase diagram. Okay, alright. Okay, so this is the Kb. This is the constant, okay, for common solvent like water, acetic acid, so benzene, chloroform, cyclohexane. So these are not so common to us lah, but for chemists maybe these are considered as common. Okay, so this is just to show you the different in constant. So different solvent may have by right, okay, have different constant. Okay, all right. So please remember the unit. If you don't remember the unit, still not a problem. Okay, like what I have shown you in the ideal gas equation last time. How we should derive from the formula. Okay, so just now the formula of boiling point depression is delta TB equal to KB times M. Okay, all right. So before that, okay, I forgot to show you what M is. Okay, it's not something new. It's what we have learned in topic 1. It's molality. Okay, molality. So we know that molality, the formula is mole of solute is equal to kg of solvent. Okay, all right. So the unit should be mole per kilogram. Or if we want to simplify this, we could just simply use M. Okay, so that is molality. All right, so come back to the unit. We can derive the unit of the constant from the from the formula itself. So we know that okay, kita transfer. Okay, let's use KB as the highlight. So we got delta TB over M. Okay, alright. So delta TB, regardless, walaupun dia delta ke whatsoever, it's still temperature. Dia still temperature. The unit should be in degree Celsius ataupun in Kelvin. So here we have in Kelvin. Okay, in this slide we do have in degree Celsius. Nampak tak? Kenapa dia boleh dua-dua? Okay, kenapa dia boleh dua-dua? Boleh in Kelvin and boleh in degree Celsius? Because we are talking about different in temperature. Kalau you tukar in Kelvin ke, you tukar in degree Celsius ke, at the end of the day, bila you tolak, you still dapat beza yang sama. You still dapat value yang sama. Provided that you have converted all the, katakanlah you want to go for Kelvin kan, you convert everything into Kelvin first. You janganlah this one you Kelvin and then yang another temperature is in degree Celsius and then you tolak. Okay, itu memang nak kena ketuk lah telinga tu, ketuk telinga. Okay. So make sure that when you minus tu, they have the same unit. Alright, so that's why it can be degree Celsius or it can also be in Kelvin. Okay, divided by molarity. If we derive further for the molarity, okay, molarity is equal to mole per kilogram. Ini dah mathematical lah, degree Celsius. When this one is transferred to the at the top, dia akan jadi terbalik, betul tak? So it will become kg per mole. So dapatlah degree Celsius apa tu? Percentage. Degree Celsius kilogram mole negative 1. Okay? So there you have your ni. Kalau nak hafal, lagi cepat. Tak hafal pun tak apa. You may derive from the equation. But please make sure to have unit in your calculation. Okay? Right? Okay, moving on. Okay, let's look at an example. Calculate the boiling point of solution when 1 gram of C3H8O3 is dissolved in 54 gram of water. Okay, so the boiling point of water is at 1 atm is 100 degrees Celsius and the Kb, the value of Kb for water is given as this. Okay, alright, so obviously we are talking about boiling point kan. So the only formula that we have for boiling point would be delta Tb is equal to Kb point blah. Kb times molarity. Okay, if we have to extend this one further, so this is what we call boiling point elevation. Okay guys, this delta Tb is what we call boiling point elevation. Okay, so this one can be expanded into delta Tb is also equal to Tb of the solution, the boiling point of the solution minus the boiling point of the pure solvent. Okay, all right, it's equal to Kb times M. So the question is asking for the boiling point of the solution, which is this one. Dia nak tahu for Tb. So by right, everything need to be available lah. Okay, whether they directly or indirectly, everything need to be there before you can calculate for the boiling point of the solution. Alright, so let's look at the information. So kita just masukkan saja the data. So Kb, we do have the Kb, which is this one. Okay, and then how about T naught B, the pure solvent. In this case, the pure solvent is water. So we know that water boils at 100 degrees Celsius. Okay, and it is already stated here. Katakanlah soalan did not give us, soalan tu dia guna water as a solvent. Okay, dia guna water as a solvent and it did not give us the boiling point of the pure solvent, which in this case tadi yang saya cakap tadi water. Okay, so perlukah anda menggelabah dekat situ? Tak perlu, because you should know that water boils at 100 degrees Celsius and it freezes at 0 degrees Celsius. So information about water like freezing point, melting point, boiling point, condensation point, okay, is considered as general knowledge. Okay, so general knowledge tu tak perlulah kita nak beritahu, nak state in the question, you should know. So water freeze at 0 degrees Celsius and boils at 100 degrees Celsius. Okay, alright. So jangan panik, ni tak bagi information ni. You kena tahu. Untuk water especially. Okay, alright. So this one kita known, this is also known and molarity can be obtained from the information given. Okay, so we know that molarity is mole of solute divided by kg of solvent. So kg of solvent, so this is already in, maksudnya dia dah bagi dalam bentuk solvent dekat situ unless dia bercampur ke apa ke, kena tolak-tolak lah sikit. Alright, so it's given already, so 54 times 10 to the power 53 kg. So mole of solute, you have to convert into mole. 1 gram times dengan apa dia punya molar mass, 92 gram. So up here we have 1 mole. So gram cancel, we got the mole. So we can simply divide and then insert the value into the formula, and finally you will get the boiling point of the solution. Okay, like what we have in the solution here. Okay, like what we have here. Okay, nampak unit pun just nice dekat situ. So kg -1 will be cancelled out with kg -1. Okay, in order for the cancellation normally, especially for molality, kalau you letak dekat situ molality, okay, baik, cuba tengok dekat situ. mm kan, kalau you letak dekat situ value dia m times dengan KB, apa dia punya formula dia apa? Katakanlah value dia kat sini berapa tadi? 0.20 molar instead of we use mole per kilogram, we use m, which is betul. Dia punya unit tu tak salah, alternatif. Okay, but if you want to use in the calculation, normally we will transform molality into mole per kilogram. Sebab kalau tak, you tak boleh cancel. Cuba tengok mol darat dengan apa? KB KB dia apa? 0.52 degree Celsius times mol. Kalau dia dah bagi M macam ni, okay, M -1 dekat situ, molality dengan M sini, bolehlah cancel. Betul tak? Dia boleh cancel. Dia depends on the information bagi dekat situ. Sometimes dia boleh bagi macam ni, 0.52 degree Celsius kg per mol. Macam ni. Kalau you masukkan dalam formula tu, kalau you maintain you tak nak tukar kg per mol, you remain the m, you tukar this one in terms of m, so you akan ada masalah lah kat situ, nak cancel out the unit. Okay, so make sure that you tahu bila nak remain as this unit ataupun bila nak convert into the alternative unit kat situ. Okay. Alright, so moving on to freezing point. Okay, so basically freezing point has the same explanation as the boiling point just now. Okay, even the formula itself, for the freezing point also is almost the same as the boiling point just now. Okay, but let's just go through very briefly on freezing point. So what is freezing point? Freezing point is the temperature at which a pure liquid changes to a crystalline solid. Okay, from liquid to solid or freezes. It is called the freezing, the temperature at which a pure liquid changes to a crystalline solid or freezes. It's called the freezing point. Benda lah macam pusing kat situ. So example, the freezing point of ice is 0 degrees Celsius. Okay, so this time around, the liquid the liquid transform into solid. Okay, so that temperature in which the liquid transform into solid and the vapor pressure, okay, as you can see, it is not mentioned in terms of vapor pressure, okay, because at the end of the day, the vapor pressure that need to be the same. Macam boiling point tadi kan, boiling point when it is said to reach the boiling point because the vapor pressure of the solution is the same as the vapor pressure at the outside. Betul tak? Because kenapa outside itu dah memang boiling point adalah proses daripada liquid jadi gas. Betul tak? Liquid jadi gas. Okay? Sekejap ya. Halo. Ya, saya cakap. Cik Ikamah ke? Saya ada kelas lah Cik Ikamah. Tengah kelas, babe. Okay, biar sambung. Bye. Alright. Where were we? Apa tadi? Freezing point. Vapor pressure. Okay. So tadi boiling point, dia nak jadi daripada liquid to gas kan. So that's why the vapor pressure of the liquid tu bila nak jadi gas should be the same as the vapor pressure dekat luar, which is the vapor pressure of the gas. Sebab dia daripada liquid nak jadi gas. Betul tak? Alright, so same goes to freezing point. Dia daripada liquid to form solid. Okay, from liquid to form solid. So in order to reach that freezing point ataupun di mana point vapor pressure of the liquid is the same as the vapor pressure of the solid. That is what we call freezing point. Ketika mana di mana vapor pressure of the liquid is the same as the vapor pressure of the solid. Okay, alright. Again, the presence of non-volatile solute will of course interfere with the freezing point, the freezing of the solution. Okay, so the addition of non-volatile solute to a volatile solvent, the resulting solution ataupun water as a solvent will not freeze at 0 degrees Celsius. Okay, so you can imagine that when we subject to the graph just now kan, okay, dia terpaksa we have to lower down the temperature further, okay, in order to freeze the solution. Okay, sebab dia depress the freezing point. Water in the solution has a lower vapor pressure than that of pure ice. So maksudnya dia tak sama kat situ. Okay, vapor pressure the other is tinggi than the other one. So as the temperature decrease below 0 degrees Celsius, the vapor pressure of the ice decrease more rapidly than that of the liquid water. So as the cooling continues, the vapor pressure of the ice and the liquid water will eventually become equal. Bila dia sama, okay, dah sama, and then the temperature at which this occur is the new freezing point of the solution, and normally it is below, usually it is below 0 degree Celsius. Maksudnya dia become more negative lah. Okay, hence the freezing point has been depressed. Okay. Okay, so how do we calculate the freezing point depression? So again, the freezing point depression, we represent it as delta TF. Okay, alright, so delta TF is equal to KF times M. M again is the molality. Okay, alright, it's just that then for this time around, delta TF is equal to T naught F minus F. T naught F minus F. As for boiling point just now, okay, it is TB minus T naught B. This is freezing point. But for this is boiling point elevation. For freezing point depression, the naught should be the one that has larger value. Dia kena larger value tolak smaller value. Okay, alright. So that's why you kena T naught F minus TF. This is opposite to the boiling point here. Kita balik ya. Nampak tak? Notice tak? Knot ni dekat belakang for the boiling point. Tapi for freezing point, the knot should be the first ataupun the one that has larger value. Okay? Ni. And then again, dia punya beza, the delta TF should be larger than 0. You should get larger than 0. Okay? Alright. So I have explained in terms of the phase diagram just now. Okay, so the focus is now here. Tadi boiling point, this one. Okay, so this is for freezing point. So as you can see, it is depressed. Pada pressure yang sama, the temperature is now lowered. Okay, alright. This is the KF, the constant of example of solvent. Okay, so different solvent may have different KF values, right? Okay, so let's look at an example for KF. Ethylene glycol C2H6O2 is a common automobile antifreeze. It is water soluble and fairly non-volatile. So we can consider this ethylene glycol as a non-volatile solute. So one of the usage of ethylene glycol is it is used as an antifreeze in the automobile. Okay, so it is used as antifreeze in automobile car atau mobil engine lah. So this is the boiling point, the pure boiling point, because we have not there. Okay, this is the pure boiling point of ethylene glycol, and this is the molar mass. So the question is asking for calculate the freezing point of a solution containing 651 gram of this substance in this amount of water. Okay, and then that will be this will be the first question. Secondly, the second question asks you to determine whether the substance can be kept in the car radiator during the summer. Okay, whether it can be kept in the car radiator during the summer. So we have two conditions here. One is during the winter, okay, because antifreeze kan, antifreeze maksudnya kita tak nak dia beku. So beku adalah pada winter lah. Betul tak? And then we have summer. Summer kita tak nak dia boil pula. Kan? So ini adalah kegunaan non-volatile solute. Tak adalah non-volatile solute ni tak baik. Dia banyak kegunaan sebenarnya. Bila kita nak manipulate the boiling point of a solvent kan. Kita nak manipulate, kita nak twist sikit je. Okay, kita nak dia increase a bit in terms of the boiling point. So what can we do? Okay, what can we do? So kita boleh add in solute. Kita boleh add in the non-volatile solute into the solvent. So dia akan dia akan adjust, the temperature will be increased for the boiling point lah. Okay, will be increased slightly ataupun sometimes it depends how much of the amount of the solute added into the solution. Lagi banyak solute is added into the solution, by right, lagi banyaklah elevation ataupun depression made to the boiling point and freezing point. Okay, alright. So kita tahu dalam kereta kita, engine kereta kita, okay, bila dia bergerak, okay, dia akan produce heat. Okay, dia akan jadi sangat panas. So the engine needs some sort of cooling system dekat situ. Dia kena ada cooling system untuk nak reduce down the temperature of the car. Kalau tak dia overheat, yang kena berhenti kat tepi jalan, lepas tu nampak berasap-asap kan. So kita tak nak itu berlaku. That means car engine tu kena ada system to cool down the engine. So one of the way paling senang adalah letak water kan. Water memang dia punya cooling effect tu. Tapi the thing about water is that water ni dia bila the car, the engine become very hot, it can be, the temperature can increase more than 100, tahu tak? Okay, it can increase more than 100. Habis water dekat dalam tu, which is supposed to cool down the engine, instead, they evaporate because the temperature is already exceeding the boiling point of the water, betul tak? Dia boils off the water, so jadi tak ada apa effect lah kalau macam tu. So, something need to be done to the water. So, how can we make sure that bila engine kereta tu panas, water tu still remain in the in the car engine. Okay, so one of the way is by adding this non-volatile solute. Bila kita letak non-volatile solute, we know that by adding this non-volatile solute, it can cause the boiling point of the water to increases due to the presence of the non-volatile solute. Okay, itulah gunanya. Kita tak mau dia boil. So bila dia tak boil, dia akan helps to cooling down the engine. Kalau tak letak this antifreeze, this is tadi yang saya cerita tu more on kalau dalam keadaan panas. Okay, kita tak nak dia boil. Macam dekat summer ni lah. Ni dekat summer ni kereta engine panas. Engine kereta panas. So kalau pakai air, dia akan evaporate easily. So kita tak nak dia evaporate, so kita add in this ethylene glycol. Okay, alright. So can you imagine the same understanding for we apply during the winter. Kalau winter apa masalah dia? kita nak winter dia sejuk. Sometimes it can go below 0 degree Celsius. We know that water, kalau kita guna the pure water, okay, kita guna pure water, dia akan freeze. Kalau 0 degree Celsius, dia akan freeze. Habis dia block lah engine tu. Dah tak boleh bergerak pula. Okay, so during the winter, we have to make sure that the water which act as the cooling agent in the car engine tu, dia remain as liquid. Bukan dalam ais lah, kita tak mau dia beku. Okay, so caranya macam mana? Kita letak again this ethylene glycol. So this ethylene glycol act as an antifreeze. Okay, so maksudnya bila kita letak, dia akan depress the freezing point. So dia menyebabkan the freezing point of the solution depress to a lower temperature. So pada 0 degree Celsius, dia taklah beku. Okay, bila tak beku, so the car engine can still be used lah. Dia tak adalah merosakkan kereta tu. Okay, so that's the idea lah. That is the application. We have a lot of application of this non-volatile solute in the solvent. Banyak sangat contoh. Baca. Contohnya kalau during the winter kan, cara orang tak nak dia jadi ais adalah kita tabur garam kan. Kenapa kita tabur garam? Sebab because of this concept lah. Okay, we do not want the ice, we do not want the water to be transformed into ice, because bila dia jadi ice, it will be slippery. Kan? Kita jadi licin. So kita tak nak jadi ice, kita nak dia remain as liquid. So one of the ways by tambah garam lah. Kalau this is for winter lah kan, during winter dia one of the way lah dia pakai garam. So the garam actually lower down the freezing point. So that means as long as they tak reach the freezing point, they still remain as liquid. Okay, so dia taklah jadi air. So tak licin lah. Alright, okay, so let's look at here. So we have to prepare everything. So the formula that we use is delta TF is equal to KF times times molality. So delta TF is also equal to T naught F minus TF. Okay, so this is the solution. This is the pure. Okay, so this is the formula. This is the constant times molality. Okay, like just now, molality should be mole per kilogram. Okay, of solvent. All right. Okay, so the question is asking for freezing point of the solution, which is this one. Soalan nak cari ni. As you can see, the question did not give us the boiling point for the pure water. Nampak dia bagi tak? Dia cakap tak the boiling point of pure water? No, it's not given because you kena tahu lah. Okay, so kat sini it should be 0 kat situ. So we want to determine this. So by right, everything need to be prepared. Okay, so that we can calculate 40 TF. Masukkan, so you dapat lah. This is the apa nama tu? The boiling point of the solution. Okay, soalan yang kedua tadi, determine whether the substance can be kept in the car radiator during the summer. Panas kan? Pada you imagine engine kereta tu dah panas, and then during the summer pula tu yang memang panas. So dia punya impact tu lebih dahsyat lah. Okay, it will the solution in the car will be easily evaporates. Dekat engine kereta tu will be easily evaporates. Okay, alright. So soalan dia, boleh tak we still be using the ethylene glycol during the summer, ataupun do we need to change to another substance? Nak letakkan dalam water tu. So bila kita kena buat apa? How do we prove that it can be used ataupun it cannot be used? We need to calculate the delta TB. Okay, we need to calculate the delta TB. So you dapatlah, this is the boiling point elevation. Kita nak the boiling point of the solution. the boiling point of the solution. Kenapa kita nak the boiling point of solution? So that we can compare dengan the pure water. Okay, how much it is increased. So bila kita check, oh dia 102 degree Celsius. So dia decrease sebanyak 2 degree Celsius. Kalau pure dia 100 kan. So kalau kita add in this amount of the same volatile solvent and the non-volatile solute into the water, kita akan dapat the increment is as high as 2 degree Celsius. 100 minus 102. Okay, kita dapat 2 degree Celsius dekat tu. Beza dia 2 degree Celsius. Betul tak? This is in terms of delta TB lah. Okay, so dia ada dia punya boiling point of the solution is 102 degree Celsius. Then again, it depends juga temperature paling tinggi yang boleh dicapai pada summer tu. Okay, turns out pada summer dia boleh reach sampai katalah 120 degree Celsius. Then ni tak sesuai lah. Betul tak? Ini tak maksudnya this amount of 651 gram okay, ethylene glycol ni is not suitable to be used during the summer, or maybe we can increase this up. Kita increase lah, mungkin dia jadi 1000 ke 1000 gram ke, okay, because we know the more solute is added into the solvent, by right it will depress ataupun elevates the temperature, okay, further. So that's the concept. That's the colligative properties. So kita boleh play around with this number, the amount of solute that we can add into the solvent. Okay, alright. So thus it would be preferable to leave the antifreeze in your car radiator in summer to prevent the solution from boiling. So kita boleh assume lah, maksudnya during the summer it still can be used. Okay, sebab kita assume yang lain tu it will not be as high as taklah sampai extreme level macam dekat padang pasir ke apa kan. Okay, so we have few checkpoints here. Okay, try to complete this checkpoint, question 1 and question 2. Okay, so question 3, you guys try to do it on your own. This is your homework. Okay, as of now, buat question 1 and question 2. Okay, we will discuss it after this. I give you like 3 minutes for you to complete these 2 checkpoints. Okay, do it now. Any questions so far? Okay ke?
Okay.
Okay, madam.
Okay, madam.
Alright, okay, good. Okay. Alright, so how are you guys doing? Okay, are you done?
Yes.
Alright, okay. How about others?
Yes.
Yes.
2, 3,
Yes.
4,
Yes, madam.
5,
Done, madam.
6,
Then madam.
7,
Yes, madam.
8, 9,
Yes, madam.
Yes, madam.
10, 11. Okay, takkanlah 40 orang seorang aja yang jawab, betul tak? Alright, okay, so let's go through question 1. Calculate the mass of ethylene glycol that must be added to 1 kilogram of H2O to give a solution that boils at 105 degree 105 degrees Celsius. The KB is already given. Okay, so this is in terms of boiling point. That means you're going to be using this EB, KB times M. Right, so dia nak tanya the mass. The mass of ethylene glycol that need to be added to this kg of water to make sure that the solution boils at 105 degree Celsius. So this is the solvent uses water. Okay, so you know that the pure solvent, the pure water will boils at 100 degree Celsius. Right? Okay, so dekat situ kita nak tahu so this one dah ada dah siap-siap dah ni 105 degree Celsius minus 100 degree Celsius. Then KB 0.512 degree Celsius, M negative 1. And then first we need to find out the M. Kenapa M? Sebab the mass may come from the mole and the mole may come from must come lah. Because that's the only yang boleh connect the connect molality and mole and eventually mass. Okay, so find out the molality first and then from the molality, you akan dapat molality kan. So molality, okay, you can to expand. It is mole of the solute divided by the kg of the solution. So the kg is already given. Okay, molality, we have determined that earlier and then we can find out the mole. And then from the mole, you can boleh terus cari mass. Okay, you boleh terus cari mass because you have 1 mole is equal to gram per the molar mass. So you cancel and eventually you dapat the mass. Okay, right. So that's the idea on how to find the mass of the solute for question 1. Okay, how about question 2? Calculate the freezing point depression of a solution that contains 5.15 gram of benzene dissolved in 50 gram of CCl4. Okay, alright. So sometimes ada ketika di mana student tak tahu yang mana solvent, yang mana adalah solute. Okay, ni normally dia bagi water will be the obvious one lah. Macam water will be the solvent lah. Okay, but kalau dia bagi in terms of maybe kita tak familiar kan which one will become the solution, which one will become solute, which one will become solvent. Okay, so the tips is to check on the mass given because solvent should present in larger amount compared to solute. Okay, so maksudnya you akan tahu dekat situ, in this case CCl4 is the solvent sebab solvent should be present in larger amount compared to solute in the solution. Solute dia sikit je, solvent lebih banyak. Right? Okay. So this is you have to calculate the freezing point depression. That means you have to calculate the TF, the delta TF. Okay, KF times M. Alright, so everything has been given. Dah masuk aje lah dalam formula tu kan. Okay, so question 3 dia special sikit. Okay, so try to do it on your own. Kita akan discuss later, which tak tahulah bila. Okay, tapi ingatkanlah. So ni dia bagi in terms of empirical formula, then suddenly Okay, lastly, the question is asking for molar mass and molecular formula. Okay, jangan terkejut soalan boleh kreatif. Dekat situ, instead of dia tanya freezing point, boiling point, molality, mass, boring kan benda tu sebab semua boleh, that one everything can be extracted from the formula. Okay, so kita boleh relate juga dengan molar mass and also molecular formula. So how do you solve for that? Okay, not to worry, okay, because whatever it is, kita ada molality, because from the molality we can extract out the mole, betul tak? Okay, kita boleh extract out the mole and later we can extract out the molar mass and whatnot. Then kita bolehlah dapat the molecular mass and seterusnya molar mass, molecular formula and molar mass. Okay, alright, so buat tu dulu, nanti kita discuss. Okay, this is the answer, the working solution for question 1. Okay, alright, so the answer is 606 gram. This is for question 2. Okay, you have to calculate the delta TF, the freezing point depression. Okay, the freezing point depression. Right. Okay. This is, lajak. Okay, all right, so that is all. So these are the references that we that we have been using, okay, in order to prepare the notes. Okay, if you are interested, you can find out the reference book. So we have Ebbing, okay, General Chemistry, and then Blackman. So ni kebetulan saya ada refer tadi kan. And this is how this is how your Ebbing reference book lah. Last time we use this textbook. We use this as our textbook. Okay, so this is 100 lebih something lah macam tu so now kita tak wajibkan lah because dia at the end of the day benda yang sama, dia chemistry juga kan, cuma different author saja, cuma how dia elaborate. So that would be one of the factor lah kenapa kita decide to use the book. Okay, but now kita tak specify. You can use any reference book. But we have the notes already for your reference. Nak baca lebih sikit, then you can go for reference. Okay, alright. Kenapa nak beritahu sekarang Dah nak topik 4 dah. Rasa dah pernah beritahu dah hari tu. Okay, alright. So that is all. Oh, okay. Tadi saya dapat message from your friend saying that we haven't discussed some of the checkpoint. Okay, so mungkin dah termiss out kot. Yang mana which checkpoint? Can you please checkpoint 13? One of it is checkpoint 13. Is that all yang kita terlepas? Jauh ni kat gas ni. 13. 14. Oh, this one. Checkpoint. This one is it? Apa tadi yang message saya?
Question 2, madam.
Question 2. Kita belum discuss Macam dah discuss belum Okay, alright. So, 1 ml of xenon effuses. Okay, this is Graham's law lah. Okay, diffusion, we'll be using Graham's law. 1 ml of xenon effuses through a small hole in 354 seconds. Calculate the time in second for 1 ml of nitrogen to effuse from the same container under the same temperature and pressure. Okay, alright. So for Graham's law, we have read. Let's just list out all the formula for Graham's law. Okay, so we have relation between rate, katakanlah rate for xenon, okay, over rate of nitrogen is equal to T of nitrogen over T for xenon, and also, okay, terbalik this one, the molar mass of nitrogen, okay, over molar mass of xenon. Okay, please make sure of this thing, guys. Okay, so the rate must be inversely proportional to time and molar mass. Okay, but in terms of time dengan molar mass, okay, dia correlate, dia tally, dia align. Okay, alright. So let's look at the information given to us. So we have volume, and we do have in terms of seconds, which is the time. Okay, so volume kita tak ada kat sini, but maybe we can manipulate this volume in order to get the rate. Okay, boleh juga kita nak manipulate 1 mil divided by 354 seconds, so that will be the rate. Okay, so banyak approach dekat sini, cuba tengok. Nitrogen, sebab as you can see, we have the information in terms of the gas used in this experiment. In this experiment, by right, if we know the identity of the gas, then by right we should also know the molar mass. Okay, so we know the molar mass of the gas, and we also know the information is also given in terms of time. Lepas tu kita boleh pakai ni lah. Boleh pakai ni. Ada juga yang nak pakai rate dengan molar mass pun boleh juga. Rate tu you boleh dapatkan 1 mil divided by 354 second. So you akan dapat mil per second. So this is what we call rate. Any measurement kita divide by time, that will be the rate. Okay? So you tak kira saya nak pakai mana? Okay, yang paling senang adalah time dengan molar mass lah. Okay, so you masuklah, instead calculate the time in second. So you nak calculate the time for nitrogen, this one. Okay, so molar mass you dah ada. Okay, you can calculate for xenon. Yeah, this one. Okay, ni soalan dia bagi dalam bentuk rate. Betul tak? Dia bagi dalam bentuk rate. You nampak tak? Kalau rate, dia 1 mil over 354. This one also 1 mil divided by time. Eventually, dia akan cancel out. Bila you naikkan this one ke atas ni, 354 second. Naikkan ke atas, dia akan terbalik. Betul tak? Which is 1 mil kat bawah, X second. Nampak tak? Okay? So, that's why you pakai approach macam mana pun, at the end of the day, dia still akan dapat jawapan yang sama provided cara tu betul lah, make sense. Okay? Alright, so this is the answer lah, 163.5 second. So what can we conclude from this? Okay, so xenon if used in 354 second, whereas nitrogen if uses in 163.5 second. So kita boleh compare dekat situ. Okay, xenon if uses xenon if used longer, okay, ataupun takes longer time to effuse compared to nitrogen. Kenapa? Because of the mass. Xenon is heavier in terms of mass compared to nitrogen. Okay? Right. If you had used the times in the numerator of the rate as opposed to being the denominator where they are supposed to be, you would have calculated an answer much larger than 354 seconds. Takes less time if you had used the times in the numerator dekat atas kan, the rate, as opposed to being in the denominator where they are supposed to be, you would have calculated an answer much larger than 354. Maksudnya apa? You guys dapat tak this value? Dapat tak?
Dapat.
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 Ni kita kena rewind sikit lah sebab ni lama ni. Ini cerita lama ni. Okay. Alright. Do we have any other checkpoint that we haven't discussed? Or we have, kecuali yang tadi lah. Okay. Yang tadi tu, satu tu kita tinggal. Ada tak lagi? Alright. So kalau tak ada, then let's wrap up this topic 4. Okay, and finally, alhamdulillah, now we can move on to topic 5. Okay, right. So by right, if we refer to our tentative syllabus, tentative syllabus, is it? Apa nama dia? Course tentative lah senang cerita every week what should we cover. Okay, so far kita kena cover sampai mana apa benda kan. So this is already week 13 guys. Okay, this week is already week 13. So we have another one more week to go and then kita done with the lecture and so on. Dah habis lah. So you're gonna sit for your exam and then you are done with semester 1. Sikit je lagi guys. One more week to go. Okay, and then plus lagi 2 week untuk revision, untuk exam, dah rehat for good. Cuti, berapa? Sebulan? Tak tahulah kan. And then semester 2. Okay, alright. So bertambah sikit je lagi. Okay. Alright. So tutup this one. Yeah, inclusive. Right. Okay. Right. So we are about to start our topic 5. Okay. Apa nama tu? Tarik nafas. Okay. Selawat banyak-banyak. Baca Bismillahirrahmanirrahim. Right, so let's start guys. Okay, Bismillahirrahmanirrahim. May Allah is, okay, topic 5, thermochemistry. Okay, so thermochemistry, the term or the word thermo means maybe the closest one would be thermometer. Okay, thermometer. So thermometer is used to measure the temperature. So temperature is the measurement for heat. Okay, heat is energy, right? So heat is energy. So chemistry, on the other hand, okay, chemistry involve reactions, chemical reaction. So we know in chemistry we have chemical reaction, and in the chemical reaction we have reactants and we have products. Okay, so during the reaction, the energy may be absorbed or evolve ataupun release. Okay, alright, so the focus of this topic is more on the energy of the chemical reaction. Okay, so last time maybe in topic 1 the focus is more on the substance itself. Okay, we have to calculate the mass, the volume of the solution and whatnot. Okay, the more on the reactant or the product itself. But this time around, okay, the focus is more on the energy involved in the chemical reaction. So that's why it is known as thermochemistry. The focus is more on the energy, and normally the energy is in terms of heat. Okay, setiap reaction should have its own whether it release energy ataupun whether it absorb energy. It's just that in topic 1 that is not our focus. Okay, that is not our focus. In topic 5 baru kita nak focus on the energy involved. Right? So that is the overview of this topic. Okay, so we have these are the subtopics that will be covered in topic 5. Okay, let's start with introduction to thermochemistry. Okay, so we have one learning objective for this subtopic, that is, okay, you have to make sure that you are able to explain the energy exchange between system and surrounding. Okay, so thermochemistry is part of thermodynamic. Okay, dia adalah cabang thermodynamic. So what is thermodynamic? Thermodynamic is the study of heat. Thermo kan? Thermo is the study of heat, and then work. Okay, we can represent the dynamic as work. Okay, dynamic, we know that it is something that is flexible. Okay, dia flexible, very dynamic, maksudnya it can be changed, it can be converted, it can be converted into something else. So that is what we call dynamic. So we know that energy can be converted. It cannot be destroyed, but it can be converted into something else. It can be converted into heat, it can be converted into work, and it can be converted into other types of energy. So that is what we call the dynamic of the energy itself. Okay, alright. We are talking about thermochemistry kan, so kita nak fokus on the energy. So thermochemistry, okay, in proper definition, is a study, okay, it's a study of quantity of heat absorbed or evolved by chemical reactions. Okay, so that is our focus. So for example, burning of fuel. Okay, so for this reaction, the heat is evolved ataupun the heat is released. Okay, for example, we have C8H18. So this is an example of fuel. So when this substance is burned in oxygen in complete combustion, we produce this products. Okay, so this reaction is exothermic because it releases heat ataupun it evolve ataupun given off the heat. That's why dia negatif dekat situ. Okay, alright. So kalau normally kita hanya ada ini saja, the balance equation only, we focus on this. Kita nak tahu the mass of the substance ataupun the volume of the carbon dioxide or water ke whatsoever kan, which we can connect them through stoichiometry. But this time around, kita ada this energy involved. Okay, whether it is being released or absorbed. Okay, so this energy dia specifically explain ataupun describe this reaction. That means for 2 mole of substance react with 25 mole of oxygen producing 16 mole of carbon dioxide and 80 mole of H2O. Okay, so it will release this amount of energy. If any of these coefficient is altered, that means this delta H ataupun the energy will also be altered. Okay, you tak boleh ubah benda ni and then ini remain the same. No, dia adalah stoichiometry juga. When you change any of this coefficient or you change any of the reactant or product, this will also be changed. Okay, alright. Katakanlah this is no longer liquid. Dia dah jadi gas pula. So that means this one, the value, I'm talking about the value but sometimes in terms of dia punya sign pun akan berubah. Okay, so the value will no longer be the same lah. Another example is melting of ice. So to melt an ice, the energy need to be absorbed. Okay, so we know that ice is in solid phase, H2O in solid phase. Okay, when it undergoes melting process, it will melt into liquid. So this process requires energy. Okay, it requires energy, therefore the positive value. It shows that the reaction absorbs energy. Okay, absorb energy. So this is positive. If any, again, the state ataupun the substance ataupun the coefficient is changed, then this also will change. Okay, alright. Alright, so system and surrounding. Okay, we are talking about thermochemistry, thermodynamic or whatsoever that is related to thermo. You have to, normally we have to specify the system, which will become the system and which one will become the surrounding. Okay, alright, so of course in thermochemistry, our focus is more on the chemical reaction itself. Therefore, that will be our system. Okay, system sebenarnya kita yang decide. Which one will become system, which one will become surrounding. Kita yang decide. Okay, contohnya, saya dekat sekarang ni, saya decide, I am the system. System adalah benda yang kita nak study. Okay, saya lah system, then the rest that in contact, that is directly in contact with me, automatically will be my surrounding. Okay, so it's azan now. Okay, let's take a break for 1 minute. Okay, we will continue after this. Okay, right, so let's continue system and surrounding. Uh, Right. So system is substance involved in chemical and physical change, which is the chemical reaction itself. Okay. So the system consists of reacting molecules. This is with respect to thermochemistry lah. Okay. Alright. Kalau tak with respect to thermochemistry, katakanlah in general, you still have to decide which one is system, which one is the surrounding. System is the maksudnya you decide katakanlah like for example tadi kan saya is a system dan everything else that is in contact with me will be my surrounding. Okay, ataupun opposite to that, instead of saya pilih saya sebagai system, I choose my pen here as my system and then saya automatically will be the surrounding of this pen. Okay, so kita boleh decide which one is which. You nak jadi system ke, you nak jadi surrounding. Tu kalau kita ada that privilege to decide lah. And then normally kita subject to question kan. And then for thermochemistry memang we are apa nama tu, the system will be the chemical reaction itself. Okay, so surrounding, like I say, everything else that interact with the system will be the surrounding. For example, the container that holds the reaction. And then you masukkan thermometer. That thermometer can also be the surrounding. And then the air, udara, that is also directly contact to the chemical reaction kan, is also the surrounding. Okay, so like what we have here. Okay, so katakanlah the solution itself is kita decide as a system, that means the rest will be surrounding. The beaker, maybe ada table dekat sini, and then ada katakanlah ada a piece of paper, okay, under the the beaker kat situ. So those will be the surrounding. Okay, so there will be a heat exchange between the system and also the surrounding. Okay, all right. So we have few types of system. We have open system, closed system, isolated system. Okay, all right. So the first one is the open system. Why is it called open? Because there will be an exchange in terms of matter and energy with its surrounding. Okay, matter we know, matter is something that has mass and volume. Okay, matter is substance ataupun anything that has mass and volume. Kita consider sebagai matter. Okay, so okay, example. Okay, we have a bottle of water here. So assume this water is slightly hot compared to the surrounding, ataupun the temperature is higher compared to the surrounding. Okay, and then the opening is not covered, so we leave it as is. So what happens is that after a while, okay, so we could kita akan rasa, and then we found out that it's no longer the temperature is no longer higher ataupun it's no longer hot compared to the initial state just now. Okay, so what actually happened there? So dekat situ the heat has been transferred from the system to the surrounding. Sebab system lebih panas daripada surrounding. So that's why the heat is being transferred to the surrounding until it finally reaches an equilibrium. Okay, heat transferred and heat absorbed will be the same. Tapi nak highlightkan lah that the heat can be transferred. Okay, and then in terms of because it is not covered kan, dia tak ada penutup dekat situ, so it can vaporize. Okay, so it will vaporize, maksudnya dia ada kehilangan mass dekat situ sebab dia vaporize. Okay, so nanti later maybe after a while you will notice that the volume of the liquid in the bottle is decreasing. So that is what we call the loss of mass. Okay, so that is open system. So yeah, hot water in an open container. So we have a lot of example because normally eksperimen kita ataupun whatever yang kita buat is considered as open system. Okay, you nampak air tumpah kan, you tumpahkan air kan, you biar je. So that you biar, you tak lap. Okay, you biar. After a while you akan nampak dia evaporate, dia vaporize kan. Temperature tu perlu ke 100 degree Celsius? Tak perlu pun. Okay, so itulah maksud saya vaporization takes place not only at boiling point. Okay, it can vaporize at any time. Itu cerita lain lah, itu cerita yang topik 4 tadi. Okay, alright. So next is closed system. Exchange energy only with its surroundings. So the difference for closed system is that now the opening is covered. Okay, we cover the opening with a lid ataupun penutup. Okay, but the rest we maintain the same as the open system. For this time around, there's no transfer of mass. The mass will not be lost to the surrounding. Okay, dia akan duduk dekat dalam tu. But the heat will be transferred. Okay, there is a loss of heat ataupun the heat will be transferred to the surrounding. So this is what we call closed system. Maybe kalau kita nak bagi dia maintain sikit ke, the least we can do is to close the lid lah. Kita closekan so that the mass will remain constant. Heat tu kita at least kita boleh study in terms of heat. Not maksudnya the mass will not affect the apa nama tu the heat transfer. Okay, so kita tahu by right bila banyak mass, that means the heat contain pun tinggi lah, banyak lah heatnya. Kalau kurang mass, the heat contain pun rendah. So kita tak nak that effect, we do not want that effect. So we maintain the mass. Okay, mass tu maksudnya the amount of water present in the bottle. So what we just want to look at in terms of the heat transfer. So at least we can do is to cover the bottle. Okay, so another type of system is isolated system. Okay, neither matter nor energy can be exchanged from system to the surrounding. Maksudnya both cannot be transferred to the surrounding because it is the neither word is used here. Okay, neither maksudnya tak boleh lah, maksudnya both of this heat dengan mass will not be transferred to the surrounding. So dia memang isolated, dia tertutup dan dia make sure that the heat also will be contained in the system. So contohnya hot water in a thermo flask. Okay, alright, moving on. Definition of heat and temperature. Okay, so heat is a transfer of energy between system and surrounding due to their temperature difference. Okay, so heat will be transferred from higher energy to a lower energy. Dia mesti ada temperature different. Without this temperature different, kita consider that the temperature is already, the heat is already in equilibrium. Okay, if there is a difference in temperature, we say, okay, yang ni lebih, the temperature is higher than than this one. Katalah you ada kotak A dengan kotak B. They are, apa nama tu, placed side by side. Okay, and this kotak A has higher temperature compared to kotak B. Okay, when you place them side by side, what actually happens is that the heat from the kotak A, which has higher temperature just now, will be transferred to the kotak B. Okay, so that is how dia punya proses. Memang macam tu, to give balance macam tu. It's all about balance. Okay, it's all about equilibrium. Okay, kalau dia tak follow equilibrium, sistem tak boleh sustain. Macam bumi kita tak boleh kalau tak ada equilibrium tu. Banyak keadaan dia mesti follow equilibrium. If this equilibrium is disturbed, so dia akan ada efek-efek lain. Okay, dia ada dominoes effect dekat situ. So that is not good lah. Tiba-tiba kita masuk sikit yang empat tu. Contohnya orang kaya dengan orang miskin. Okay, kalau kaya sangat, miskin. Ni difference lah ni. The difference will be very large. That's why, okay, kita kena, maksudnya Allah kata kita kena, kalau yang kaya tu kena bersedekah. Okay, supaya kita dapatkan that equilibrium. Kita sedarlah, maksudnya jangan ingat mendongak je dekat atas tu kan. Kita dia kaya, nanti kita boleh miskin balik. Okay, tiba-tiba cerita itu. So it's all about equilibrium lah. Okay, balance. So nak cakap kat situ, dia will be transferred if there is a temperature difference. Kalau tak ada temperature difference, that means dia punya heat transfer tu is in equilibrium. Transfer, absorb balik. Transfer, absorb balik. Transfer, absorb. Okay, kalau tak dia transfer je. Rate of transfer tu lebih laju. Right? Okay, so the temperature on the other hand, which is normally measured in Kelvin, is the degree of intensity of heat present in a substance or object. So like I said, temperature is a measurement to measure the intensity of the heat. Macam mana you kata benda tu panas? You mesti ada measurement dekat situ. Panas lah benda ni. Kan? Sebab yelah kita tak pakai lah thermometer. Thermometer tu to get the exact value of the temperature kan. But the moment kita kata dia panas is because of you are referring to the temperature sebenarnya. The temperature is higher compared to normal. Katakanlah you pegang karipap yang baru goreng dengan karipap semalam. Kenapa you kata karipap baru goreng ni panas? Okay, because of the temperature. Okay, you measure in terms of the heat sebenarnya, the intensity of the heat. Right? Okay, so we can represent the heat as Q. Okay, Q represent the heat. So we have plus Q and negative Q. Okay, if we are talking about the system, kenapa it is plus Q? Because the system absorb the heat. Okay, the system absorb the heat. We know that heat is one type of energy. Dia adalah sejenis energi lah. Dia dalam bentuk heat. Okay, kenapa dia tambah dekat situ? Okay, because system now, okay, system now absorb the heat. Dia receive the heat. So what actually happened to the energy of the system? Energy of the system now become extra. Dia dah ada extra energy lah. Sebab dia absorb the heat. Ada extra heat dekat situ. So the energy of the system increases. Okay, bertambah. So that's why we use the tambah punya sign. Okay, positive sign. So opposite to that, we have negative Q. Negative Q, it means the system evolve heat ataupun release heat ataupun given off the heat to the surrounding. Okay, dia mesti sistem dengan surrounding dia dua-dua ni dia berlaku serentak. Kalau seorang release, the other one should be absorbing. Okay, kalau seorang absorb, the other one should be releasing. So kalau sistem evolve heat, maksudnya dia release the heat. So dia hilang the dia lost the heat to the surrounding. So what happened to the energy of the system? This is with subject to the system. So the energy of the system now has less heat lah. Okay, has less heat. So less tu menunjukkan dia negatif. Okay, dia dah hilang heat tu. So currently the energy of the system has less heat than the initial state just now. Okay. Alright, so again, this is in terms of system and surrounding. Yang ni system saja, tapi saya dah relate kan dengan surrounding kan. So the system can change ataupun exchange energy in terms of heat with the surrounding. Okay, if the system releases heat, then it should be negative. So like what we have here, okay, so surrounding, okay, if system lost heat, it lost kepada siapa? It will lost heat to the surrounding lah. Okay, so the energy of the system, dia hilang energy kan, that means it will be negative. Okay, because the energy of the system is now less than the before. How about the surrounding? Surrounding become positive. Kenapa? Because it is now accepts energy from the system. So the energy of the surrounding is now increases. Okay, dia kena balance dua-dua ni. Kalau seorang hilang, seorang lagi akan bertambah. Barulah balance. Okay, dia tak boleh hilang macam tu. Satu dia tak boleh explain macam mana dia hilang tu. Okay, dia tak tally lah kat situ. Okay, alright. So and vice versa. So this is the vice versa. Okay, terbaliklah. Kalau sistem pula yang absorb the heat, maksudnya where did the system gain the energy from the surrounding? Okay, so surrounding pula hilang heat. So that's why the surrounding punya energy is now negative. Okay, please take note that delta E is change in internal energy. So internal energy we represent it using E. E means internal energy of the system. Okay, alright, so delta E is equal to Q plus W. E, like I said, is the internal energy. And then bila kita keluarkan the energy, it can be in the form of heat or it can also be in the form of work. Contohnya lah, you makan kan. You makan nasi kenapa? Nak ada tenaga lah kononnya kan. You makan because you want the energy. So bila dia internal energy lah, okay, dalam body kita, maksudnya belum dikeluarkan lagi, dia adalah internal energy. So bila kita nak keluarkan the energy, okay, so one of the way to use the energy is by heat, by releasing heat. Maksudnya kita mengeluarkan haba. Okay, kita tak buat apa-apa pun. Work, saya tak buat apa-apa pun. Saya tak bercakap pun. Imagine saya tak bercakap okay. So I did nothing, right? So Tapi jangan ingat saya I mean the energy is not being released. Okay, the energy is being released in terms of heat. Saya still mengeluarkan haba. So that one delta E is equal to Q. Okay, and sometimes ada juga dia release heat tu memang akan release lah. Kalau kita sebagai manusia kan, it will still be released and at the same time we are doing work. Contohnya saya bercakap ni, saya release heat and also I'm doing the work. So the work that I'm currently doing is talking. Okay, talking to you guys. So that is the work. So in this case, the internal energy, okay, is equal to Q plus W. Right? Sebab bukan saja saya release energy, saya juga buat kerja dekat situ. So this is normal lah. Okay? Alright, remember kita kena relate with chemical reaction. Okay, so chemical reaction normally dia tak buat work pun. Dia tak buat physical work. We do have chemical reaction that will be transformed, the energy will be transformed into work. Tapi normally kalau normal reaction tu, you ada nampak ke ada pergerakan berlaku kat situ. So everything will be in the reaction mixture. Maksudnya in terms of molecular punya movement ke whatsoever. Okay, so that would be kita tak consider work dari segi molecular view lah. Okay, but not physically. Bukan secara fizikal yang kita buat work tu. But normally kalau ada work, okay, normally it would involve gas. Maksudnya the reaction produce gas ataupun involve gas lah. Okay, when the reaction involve gases, that means ada possibility that it will perform work. Okay, either dia done by the system ataupun done to the system. Okay, maksudnya sistem tu, reaction tu ada melakukan kerja. Biasanya dia buat bila dia involve gas. Remember gas? Imagine a piston. Okay, gas tu kalau buat reaction, it produce gas and it will push up the piston. Piston akan naik. Itu kerja lah. Itulah kerja yang gas tu buat. Okay, and that gas is produced from the chemical reaction. Betul tak? Tapi tak semua reaction produce gas, betul tak? So ada yang, kalau yang tak produce gas, that means tak adalah work ni. Okay, kalau yang produce gas adalah work, tapi itu pun if only we contain the gas. Kalau kita biar je gas tu release, tak collect the gas, that means kita boleh assume there's no work done by the system. Okay, so dia depends. Kita nak study. Okay, nak study ke tak nak the work, ataupun kita focus on the heat only. Okay, alright, so work is equal to negative P times delta V. Right, so P dengan V ni maybe rasanya dah familiar by now, you are already familiar with ideal gas equation, PV/nRT. So dia actually come from this one actually come from the PV/nRT. So if you want to know more about how the derivation of the ideal gas and finally kita dapat this work, okay, formula, bolehlah cari. Okay, of course kita tak cover in our syllabus. Kita just tahu work is equal to P times delta V. And then it is negative sign because the work is done by the system. Sistem yang buat kerja tu. So kalau sistem buat kerja, maksudnya sistem akan hilang energy. Energy is lost by doing work. Okay, that's why dia ada negatif dekat situ. Right? Okay, so in general we can conclude that if system lost heat ataupun the energy flows from the system to the surrounding, that means the energy of the system is less than zero. Maksudnya dia berkurang lah, energy tu berkurang and the value should be negative. And vice versa. Okay, kalau dia terbalik, that means it should be positive. The energy is being transferred to the system, then the energy of the system become increase, okay, and in terms of value, it should be positive. And on the other hand, surrounding, dia akan terbalik lah, it should be negative. Remember kita ada system and we have surrounding. Kalau sistem kita macam tu, surrounding should be the opposite of the system. Okay, alright. Okay, checkpoint 1. The process of dissolving ammonium nitrate in water makes the solution cold. Okay, determine the sign of Q of the system and explain the energy exchange between the system and its surrounding. So the moment ammonium nitrate dia masuk dalam water, okay, it produces a cold solution. Bila you rasa, you akan rasa cold, sejuk. Okay, what actually happened there? Okay, is it this reaction, is it endothermic reaction ataupun exothermic reaction? They absorb the heat ataupun they release the heat? What would be your answer? Is it endothermic or is it exothermic, guys? Apa, Kapan? Dia release heat ke system tu, the system itself? It releases heat ke ataupun it absorb the heat based on the statement given there?
Release.
Release heat.
Release heat.
Release.
Absorb.
Are you sure it releases heat? Kalau dia release, makes the solution cold.
Endo.
You rasa solution, macam mana dia cakap solution cold? Bila you rasa sejuk lah. Betul tak? Macam mana dia boleh rasa sejuk kat situ? Kalau dia release heat, the surrounding will accept the heat. Patutnya the temperature goes up, betul tak? And then you akan rasa panas. Betul tak? Tapi ni opposite dengan statement yang dia bagi tu. Ni lagi satu Okay. Sebab you, okay, contoh, okay? You pegang ais kan? You kata dia sejuk. Okay? Since you dah belajar science, you dah belajar chemistry, you must be able to explain why do you feel cold when you hold an ice on your, dekat tangan you. Kenapa you rasa sejuk? And vice versa. Kalau you pegang something yang hot, kenapa you rasa panas? The reason dia rasa sejuk adalah, katakanlah you depends, like I said, you depends siapa sistem you. Katakanlah sistem tu adalah ais. Okay, ais tu you pegang, you rasa sejuk. Kenapa you rasa sejuk? Again, ini difference in difference in energy, difference in temperature. Okay, our hand and ais tu. Okay, so the temperature of the ice is lower than the temperature of our hand. Okay, alright. So the ice tu dia melt sebab dia absorb the heat from our hand. Okay, from our hand. Kalau dari segi perspektif tangan pula, apa yang berlaku pada tangan tu? Tangan tu lost heat to the ice. Bila dia lost heat, energy hilang tau ni. Energy hilang, heat tu hilang. Bila heat hilang, heat dah kurang. So you patut apa? You patut rasa apa? You patut rasa sejuk lah sebab heat yang memanaskan tu dah kena ambil dengan ais. Ais yang ambil. And then ais tu mencair. Okay? The reason you rasa sejuk is because of the heat is being transferred from your hand to the ice. The heat is lost. Kalau perspektif ice tu pula, the ice absorbs the heat from the hand and eventually melts. So bila dia absorb the heat, okay, bila dia absorb the heat, dan dia akan cair dekat situ. The heat is used to break the forces lah kan, nak break the forces so that they become liquid. Same goes to kalau you pegang something yang panas. Pegang apa yang panas? Pegang karipap lagi sekali. Karipap tu bau goreng. Sedap je dengan karipap. Karipap tu bau goreng, you pegang. Kenapa you rasa panas in the first place? Okay, the reason you feel hot is because of siapa yang panaskan kan? karipap yang panas tu, okay, and then tangan kita kan sejuk kan. So the heat will be transferred from higher temperature to lower temperature kan. So heat tu will be given off. Okay, will be given off and then the hand will absorb the heat. Okay, bila you terima heat, you akan rasa panas and temperature increases. Okay, then maksudnya dekat sini karipap is exothermic sebab dia hilang energi, betul tak? Dia hilang energi. Tangan kita is endothermic because they accept the heat from the karipap. Okay, they accept the heat from the karipap. And the heat of the tangan, tangan kita, katalah tangan kita is our system, the energy increases. Faham tak? Dari segi macam tu. Okay, so bila you kata panas sejuk apa tu, you must be able to explain in terms of that. It's because of the heat transfer dekat situ. So janganlah cakap bila sejuk, sejuk lah sebab ais kan. Okay, detail sikit. Kenapa you rasa sejuk, kenapa you rasa panas. Kenapa masa aircon sejuk 16 degree Celsius tu, you rasa sejuk. Because apa, badan kita cuba nak samakan. Maksudnya dia akan release the heat. Because badan kita panas, keadaan sejuk. So dia akan nak try to equilibrium kan. So the way is to release the heat to the surrounding. Okay. Itu sebab reason you rasa sejuk. So, subject to our question here, makes the solution cool. So, ni kita boleh measure the solution tu, kita rasa sejuk. Kenapa dia rasa sejuk? Because the heat is being absorbed. Dia ditarik daripada surrounding to help the dissolution of this ammonium nitrate. Okay? Faham? So, dia punya sign should be apa? Positif ke negatif?
Positif.
Okay, so it should be positive. Explain the energy exchange between the system and its surrounding. So it is being transferred from system jadi ni kan. So the system absorbs the heat from surrounding. Okay, the system absorb the heat from the surrounding ataupun the surrounding lost heat to the system. Okay, the surrounding lost heat to the system. Maksudnya heat dia tu is absorbed by the system lah. Saya asyik ulang yang sama je kan. Okay, so should be positive, energy is absorbed by the system from the surrounding. Okay. Alright, so this is the unit of the energy. So we're going to be using the joule. Okay, alright, so this is the definition of joule. So dia ada kena-mengena dengan energy. So to measure energy, one of the unit is joule. Okay, alright, so this is to be specific lah for 1 kilogram and then the speed is 1 meter squared per second. So 1 joule is equal to 1 kg M2 as negative 2. Okay, or alternatively we can also use 1 kilojoule is equal to 1000 joule. We can convert 1 joule into kilojoule. Okay, so 1 kilojoule is equal to 1000 joule. Alright, so that is all. So next subtopic will be 5.2, enthalpy of change of reaction delta H. Okay, right. So the time is up already. So for this one, okay, just to give you the highlight. Okay, enthalpy change of reaction. The reason it is used as delta H, not delta E. Kenapa? Like I said just now. Okay, E is equal to Q plus W. Chemical reaction. Okay, normally the transfer of energy itu is in terms of Q. Okay, kalau dia produce gas and then the gas tu kita collect and do something about the gas, then maybe work is involved there. Okay, so normally the heat absorbed release tu is in terms of Q lah, the Q. So to differentiate the E ni dengan heat daripada chemical reaction, okay, we assign a term for that and it is known as enthalpy of reaction. It is delta H, not delta E. Okay, for chemical reaction di mana ada buat kerja macam kita berlari ke apa kan, yang kita boleh nampak secara real tu. Kita tak nampak benda tu kan, yang kita rasa panas, sejuk, okay. Alright, so for chemical reaction we measure in terms of enthalpy, delta H instead of E. Okay, because for E dia ada Q dan W. Q ni not a problem, W ni kita tak applicable sometimes for the reaction. So we assign something yang to describe for chemical reaction, the energy involved for chemical reaction, and it is known as delta H. Okay, alright, so that is all for today. Okay, any questions so far, guys? No reaction. Okay, alright, so that is all